Hello there, and welcome to the Sleepy Space Channel. Saturn's moons are the only worlds beyond Earth that hand a visitor familiar things, and that is exactly what is wrong with them. On Titan there is a shoreline, and the liquid filling it is fuel. There is weather, and the rain is methane, and it falls about once every 30 years. There is an atmosphere at a pressure a body handles comfortably, with no oxygen anywhere in it. Next door, a moon is spraying its own ocean into space, over ground that will not hold a footprint. Tonight we take Titan and its neighbors one familiar thing at a time. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is anything you need to carry. Nothing out there is waiting on you tonight. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away. Let's begin. Part 1. The system that says yes. Saturn sits about 9.5 times further from the Sun than Earth does. That is roughly 1.5 billion kilometers, and the number is worth holding for a moment, because everything else about the system follows from it. Sunlight weakens with the square of distance. At Saturn, the Sun delivers about 1% of the energy it delivers here. 15 watts fall on a square meter out there, against 1,361 on a clear day at home. The Sun is still the brightest thing in that sky by an enormous margin. It is simply no longer a source of warmth in any sense a body would recognize. Light itself takes about 80 minutes to cross the gap in one direction. A message sent from Earth and answered the instant it arrives comes back after roughly 2 hours and 40 minutes. There is no conversation with Saturn. There is only correspondence, sent into a delay and read much later. That single fact quietly removes most of the ways human beings normally handle trouble, and it will come back at the end of this episode when we look at what the distance actually costs. Saturn takes about 29.5 Earth years to complete one orbit. Its own day is short, a little over 10.5 hours, but its seasons are 7.5 years long, and every moon in the system inherits those seasons whether it wants them or not. A person could spend an entire working career on one of these worlds and watch the weather pattern shift exactly once. And yet the odd thing about the Saturn system, the thing that makes it worth an episode of its own, is how welcoming it looks from a distance. Almost every other destination in the solar system announces its hostility immediately. Venus is a furnace under a crushing sky. Mercury has no air and swings hundreds of degrees between light and shadow. The inner moons of Jupiter sit inside a radiation environment so severe that an unshielded human standing on Europa would absorb a fatal dose within a day. These are worlds that say no in the first sentence. Saturn's moons say yes. They say yes in a dozen different ways, and every one of those yeses is the subject of tonight's video. Start with the sheer number of them. Saturn has more moons than every other planet in the solar system combined. The confirmed count is well past 200, and it climbs every time a survey gets more sensitive to small, faint, distant objects on strange orbits. 7 of those moons are large enough that their own gravity has pulled them round. One of them is larger than the planet Mercury. This is not a planet with a few companions. It is a system with a population. Then consider the radiation environment, because this is where the Saturn system earns its reputation for gentleness. Saturn does have a magnetic field, and it does have belts of trapped particles, but the scale is nothing like Jupiter's. Saturn's magnetic moment is a few hundred times Earth's. Jupiter's is roughly 20,000 times Earth's. The difference in what those two fields do to a human body is not a matter of degree. It is a matter of category. There is a further mercy in how Saturn's belts are structured. Charged particles spiral along magnetic field lines and eventually run into something. In the Saturn system, that something is usually a ring particle or a moon. The rings and the inner moons act as a sponge, absorbing the particles that would otherwise build up into intense belts. There are gaps carved directly into Saturn's radiation belts by the orbits of its own moons, corridors of relative calm swept clean by the bodies passing through them. It is worth pausing on how that population is arranged, because the arrangement explains a great deal. Saturn's moons fall into three distinct groups. Closest in are the small shepherds and ring moons, orbiting almost exactly in the ring plane on nearly circular paths. Beyond them sit the mid-sized icy worlds, the ones with names and geology and, in several cases, oceans. And far outside those, in a wide and untidy swarm, are dozens of small, irregular bodies on steeply tilted orbits, many of them traveling backwards relative to everything else. That outer swarm was almost certainly captured rather than formed in place, which means Saturn is holding on to material that began its existence somewhere else entirely. Saturn's magnetic field is also almost perfectly aligned with its rotation axis, tilted by less than 1/10 of a degree. Earth's field is tilted by about 11 degrees. Jupiter's by about 10. Saturn's is aligned to a precision that planetary dynamo theory still struggles to explain, and whatever the reason, the practical result is a magnetosphere that behaves in an orderly way, without the violent 10-hour dose cycle that sweeps across Jupiter's inner moons as its tilted field rotates past them. So the picture that assembles itself is genuinely encouraging. A large family of worlds. A manageable radiation environment. Water ice everywhere, in effectively unlimited quantity. One moon with a thick atmosphere. Another moon venting a liquid ocean directly into space where anything passing by can sample it. Compared with the alternatives, the Saturn system looks less like a hazard and more like an opportunity. That impression is the reason for tonight's episode, and it is also the thing this episode is going to take apart. Here is the shape of the problem, stated plainly, and then demonstrated 11 more times over the next 2 hours. Saturn's moons are the only place beyond Earth that hands a visitor recognizable things. There is a shoreline out there. There is weather. There are rivers with tributaries and deltas and canyons. There are beaches and dunes and sand. There is an atmosphere thick enough that a human being could stand in it without a pressure suit, breathing from a tank, wearing something closer to a coat than to a spacecraft. There is an ocean under ice, and in one place that ocean comes up out of the ground on its own. Every one of those familiar things is made of the wrong material. The atmosphere has no oxygen in it anywhere. The rain is not water. The rivers do not carry water. The sand is not rock. The bedrock is not stone. The beaches are not mineral. The ocean is buried under 20 kilometers of ice that behaves like granite. The mountains have no accepted explanation, and the sky that would show a visitor the most famous object in the solar system does not show it at all. This is a system built out of substitutions. Each one has the right shape and the wrong substance. Individually, none of them is fatal to the idea of living there. Everyone has an engineering answer, and most of those answers are already sketched out in some detail. The trouble is structural rather than individual. Every substitution that gets solved reveals another one underneath it, and the solutions interfere with each other. The insulation that keeps a body warm has to flex, and the materials that flex are the ones that fail in the cold. The fuel is everywhere, and the oxidizer is nowhere. The one moon with a breathable pressure has no light to grow anything by. That is the audit we are going to run tonight, one substitution at a time, in the order a settlement would actually meet them. We will spend most of the time on Titan, because Titan is where the substitutions are richest and where any serious human presence in the system would begin. But Titan is not the whole story, and the rest of the family matters. Enceladus offers the most interesting chemistry and the least usable ground. Mimas hides an ocean under a surface that shows no trace of it. Hyperion is barely solid enough to land on. Iapetus has a wall across its equator, 20 kilometers high, that nobody can explain, and it holds the only good view of Saturn's rings anywhere in the system. And the rings themselves, which look from a distance like the one solid floor in the outer solar system, turn out to be the emptiest place of all. None of this is a warning. There is nothing out there that intends anything. Saturn's moons have been doing exactly what they are doing for billions of years, and they will keep doing it long after every question in this episode has been answered or forgotten. What makes them worth an unhurried look is not danger. It is the particular quality of resembling home while being made of something else entirely. So settle in, and let us begin where any visitor to the Saturn system would begin, with the one moon out there that has a sky. Part 2. An atmosphere you could stand in. Titan is about 5,150 kilometers across. That makes it the second largest moon in the solar system, and it makes it larger than the planet Mercury. If it orbited the Sun on its own, nobody would hesitate to call it a world. It orbits Saturn instead, at a distance of about 1.2 million kilometers, taking just under 16 days to go round once, and it keeps the same face turned inward the entire time. What sets Titan apart from every other moon anywhere is the sky above it. Titan has a real atmosphere. Not a wisp, not an exosphere measured in nanobars, not a thin haze of gas knocked off the surface by radiation. A genuine, thick, permanent atmosphere with weather in it. The pressure at Titan's surface is about 1.45 bar. That is roughly 45% higher than sea level on Earth. It is the pressure a diver feels a few meters underwater. It is comfortably inside the range a human body handles without difficulty. This is the single most important fact in tonight's episode, and it is entirely true. A person standing on the surface of Titan would not need a pressure suit. There is no risk of decompression, no need for a rigid shell, no need for the counter-pressure garments that make working in vacuum so exhausting. The environment is not trying to pull anyone apart. It is pressing gently inward, at about the pressure of a warm day at the bottom of a swimming pool. The composition is just as encouraging on first inspection. Titan's atmosphere is roughly 95% nitrogen. Earth's is about 78% nitrogen. In bulk terms, Titan's air is the closest thing to Earth's air anywhere in the solar system, and it is not close by accident. Both atmospheres are dominated by the same inert molecule for related reasons involving what a young world can hold on to and what it loses. The rest of Titan's atmosphere is a few percent methane, a trace of hydrogen, and a long tail of heavier organic compounds produced where sunlight takes the methane apart high above. Because Titan's gravity is weak, the atmosphere is not held down tightly against the surface. It extends upward for something like 600 kilometers, roughly 10 times deeper than Earth's. Seen from outside, Titan is a small orange ball inside a much larger soft-edged shell of haze. In terms of the amount of gas standing above each square meter of ground, Titan carries proportionally more atmosphere than any other solid body in the solar system, including this one. So Titan gives a visitor pressure, a nitrogen atmosphere, and a sky. And then comes the substitution. There is no oxygen. Not a usable trace, not a reserve locked in a mineral anyone can reach easily, not a seasonal cycle that produces a little of it. Titan's oxygen is bound up in water ice, in the crust, in the ocean far below, and in small quantities of carbon monoxide and carbon dioxide present at parts per million. The atmosphere a person could stand in without a suit is an atmosphere that would kill them in under a minute if they took off the mask. The way it would happen is worth understanding because it differs from the way people usually imagine it. Nitrogen is not poisonous. There is no chemical attack, no burning sensation, no irritation of the eyes or throat. The failure is purely the absence of something. Breathing pure nitrogen does not merely fail to deliver oxygen to the blood. It actively strips oxygen out of the blood because the exchange in the lungs runs in whichever direction the concentration gradient points, and with no oxygen in the incoming gas, that direction is outward. Consciousness goes in a handful of breaths, without pain and without any warning the body is capable of generating. This has a practical consequence inside a habitat that engineers take seriously. Titan's atmosphere is odorless, colorless, non-irritating, and at a comfortable pressure. A leak of outside air into a living space announces itself in no way whatsoever. There is nothing to smell, nothing to taste, nothing to feel. Detection has to be entirely instrumental, and the instruments have to be trusted absolutely, because a human being standing in a slowly filling compartment would receive no signal at all until the signal stopped mattering. There is a second consequence, and it inverts one of the oldest assumptions in engineering. Nothing can burn on Titan. Combustion requires fuel and an oxidizer, and Titan's atmosphere supplies fuel in abundance and no oxidizer at all. A match struck in the open air on Titan simply goes out. A fire in a workshop, given an open door, extinguishes itself. That sounds like an advantage until it is followed through. Every process that a settlement might want to run using combustion, heating, welding, generating power from chemical energy, cooking in any conventional sense, requires oxygen shipped from Earth or extracted at enormous energy cost from ice. And the direction of danger flips completely. On Earth, a habitat worries about fuel leaking into an oxygen-rich space. On Titan, the entire outside world is fuel, and the habitat is the only concentrated oxidizer for 1 billion kilometers in any direction. It is not methane getting in that presents the hazard. It is oxygen getting out. The density of the air changes other ordinary things as well. Sound travels at about 194 meters per second at Titan's surface, slower than it does here, and the dense cold gas carries low frequencies with unusual efficiency. A voice on Titan would sound deeper and would carry further than it does on Earth, which is a strange detail to sit with, given that no one could ever hear it without a helmet in the way. Higher up, the atmosphere behaves less politely. Titan's stratosphere superrotates, circling the moon far faster than the moon itself turns, with winds running at something like 200 meters per second, while the air at the surface barely moves at all. And several hundred kilometers above the ground, in the ionosphere, sunlight is assembling large negatively charged organic molecules out of nitrogen and methane, which then drift slowly downward through the whole depth of the atmosphere toward the surface. The sky on Titan is manufacturing something and letting it fall. There is one more piece of unexpected good news before we leave the atmosphere, and it concerns radiation. The column of gas above Titan's surface has roughly 10 times the shielding mass of Earth's atmosphere. Cosmic rays arriving from outside are absorbed high in that column and never reach the ground. Titan spends most of its orbit inside Saturn's magnetosphere, out at about 20 Saturn radii, and when the solar wind is strong enough to compress the magnetosphere, Titan briefly finds itself outside it. Either way, it does not matter much, because the atmosphere is doing the work rather than the field. The result is the best radiation environment on any solid surface beyond Earth. Surface dose on Titan is comparable to, or lower than, the natural background a person absorbs standing outdoors at sea level here. On Europa, out at Jupiter, the equivalent figure would be lethal within a day. On Titan, it is unremarkable. And that, more than anything, is why Titan is dangerous to reason about. It removes the hazard everyone expects and leaves in place the ones nobody has intuitions for. Finally, the atmosphere does one thing that is simply a pleasure to describe. Titan's surface gravity is about 1.35 meters per second squared, roughly a seventh of Earth's and a shade less than the Moon's. Its surface air is 4 to 5 times denser than sea level air here, because it is very cold and slightly compressed. Lift depends on air density. Weight depends on gravity. Multiply a seventh of the weight by 5 times the density, and human-powered flight becomes straightforwardly possible. A person on Titan wearing a modest pair of strapped-on wings could fly by flapping them. Not glide, not fall slowly. Fly, under their own muscle power, the way people have wanted to since long before anyone knew what a moon was made of. It is one of the very few places in the solar system where the human body has enough power to leave the ground on its own. The same physics makes machines efficient there. A rotorcraft on Titan needs a small fraction of the power an identical machine needs on Earth. Flight is the natural way to move around that moon, and it always will be. It also means a stumble is a slow event. A person tripping on Titan takes several times longer to reach the ground than they would here, with plenty of time to think about it on the way down. In an environment where every other property is working against a human being, that one is a small and genuine kindness. Part 3. Warmth made of the wrong material. The surface temperature on Titan is about 94 Kelvin. Converted into more familiar units, that is roughly 179 degrees below zero on the Celsius scale, or 290 below zero on the Fahrenheit scale. It is cold enough that the water ice making up the ground has the mechanical properties of rock, and cold enough that methane, which on Earth exists only as a gas, sits at the surface as a stable liquid. What is unusual about that temperature is not how low it is. Plenty of places in the outer solar system are colder. What is unusual is how little it varies. Titan's atmosphere is thick, and thick atmospheres move heat around. Circulation carries warmth from the equator toward the poles and evens it out. The result is a surface where the temperature difference between the equator and the pole amounts to only a few degrees, and where the difference between local day and local night is smaller still. There is no warm region and no cold region. There is no noon. Titan is one temperature, everywhere, all the time. The other moons run colder and less evenly. Enceladus averages around 75 Kelvin and falls into the 30s in ground that never sees sunlight, though the terrain beside its south polar fractures runs far warmer. Iapetus reaches about 130 Kelvin on its dark hemisphere, which is the warmest surface temperature in the entire moon system, and would still freeze a human being solid in a matter of minutes. Now here is where a piece of intuition that works everywhere else in space breaks down completely. Heat leaves a warm object in 3 ways. It conducts into whatever the object is touching. It convects away as that surrounding material moves and is replaced. And it radiates outward as infrared light. In a vacuum, only the third of those operates, and radiation is slow. This is why the engineering problem in a spacesuit on the moon is not staying warm. It is getting rid of heat. A working human body produces about as much power as a bright light bulb, and inside an insulated shell in a vacuum, that heat has nowhere to go. Lunar suits carry radiators and sublimators for exactly this reason. The moon is cold, and a person in a suit there overheats. On Titan, all three mechanisms are running at once, and two of them are running hard. The surrounding medium is a gas 4 to 5 times denser than Earth's air. It is 180 degrees below freezing, and it is in continuous contact with every square centimeter of a suit's outer surface, flowing gently past, carrying heat away, and being replaced by more cold gas immediately. The heat loss is not comparable to standing in cold air on Earth. It is closer to being immersed in a cold fluid, because in every way that matters to thermodynamics, that is what it is. A person exposed to Titan's atmosphere without heavy insulation loses body heat far faster than in the coldest air anywhere on this planet. Antarctic air is both warmer and much thinner. Survival is a question of minutes, and the failure is not dramatic. It is a steady, quiet draining of heat that no amount of shivering can keep up with. So the suit for Titan is not a pressure vessel. It never needed to be. It is a thermos. Its dominant design requirement is insulation, backed by active heating, and it needs to be sealed only well enough to keep an oxygen supply in and methane out. That is a fundamentally different machine from a suit built for vacuum, and in some respects a simpler one. It is also a much heavier one, because insulation is bulk. This inversion runs through the whole settlement, not just the suit. Radiators become heaters. Thermal management, the discipline that on every other world is about dumping excess energy, becomes about hoarding it. Every structural member that passes from the warm inside of a habitat to the cold outside becomes a thermal short circuit, conducting heat straight out into the environment. Legs, brackets, mounting points, and airlock frames all have to be designed as thermal breaks first and structures second. And there is a subtler problem underneath the building itself. A heated habitat sitting on Titan's ground warms the ice beneath it. Ice at 94 Kelvin exposed to a warm floor does not simply melt into a puddle. It sublimates, and it softens, and the building slowly sinks into a depression of its own making. Foundations on Titan have to be thermally isolated from the surface, or the structure excavates its own pit over the course of years. The atmosphere makes that worse in a way that is almost pretty. Titan's air near the surface is close to saturation with methane. A warm object does not merely lose heat to its surroundings. It evaporates methane out of the damp ground around it, and that vapor condenses in the cold air just above. Any heated structure on Titan would stand inside a permanent low fog of its own making, produced by nothing more than the fact that it is warm. We know the ground is damp because of what happened when a probe landed there. Its instruments recorded a small spike in atmospheric methane at the moment of touchdown, exactly as would happen if the machine's own residual warmth had boiled a trace of liquid methane out of the soil it had just settled into. That reading is one of the quietest and most informative measurements ever made on another world. It says the ground holds liquid, and it says the ground reacts to the presence of anything warm. Then there is what 94 Kelvin does to materials, which is a problem that receives less attention than it deserves. Most ordinary steels have a temperature below which they stop being tough and become brittle. That transition sits far above Titan's surface temperature for many common alloys. A steel bracket that would bend under load at room temperature will, at 94 Kelvin, shatter instead. Only certain materials stay ductile that cold, particular stainless steels, several aluminium alloys, titanium, and some nickel alloys. Every component of a Titan settlement has to be chosen from that shorter list, and the list gets shorter still once cost and manufacturability are considered. Elastomers are worse. Rubber, synthetic seals, gaskets, O-rings, and flexible hoses all lose their elasticity as they cool, and long before 94 Kelvin they behave like brittle plastic. This is a serious difficulty, because the seals are precisely the components keeping breathable air inside the habitat and keeping methane outside it. The materials that do that job on Earth are the first ones to fail on Titan. Lubricants freeze solid. Every bearing, hinge, joint, wheel, and airlock mechanism either runs dry with solid film lubrication or has to be kept warm continuously. Batteries lose most of their usable capacity at cryogenic temperature and must also be kept warm, which costs power, which is what the batteries were supposed to be providing. And every suit has flex points. Elbows, knees, shoulders, and most of all, fingers. Gloves are the hardest problem in spacesuit design on any world, because a glove has to be thin enough to work with and thick enough to protect. On Titan, a glove has to be thin enough to work with, while insulating a hand against dense gas at 180 degrees below freezing, in continuous contact, for hours. Not pressure, not radiation, not toxicity. Hands. All of this converges on a single dependency that deserves to be stated clearly. On Titan, the power supply and the heating system are the same machine. A nuclear source is doing double duty. It generates electricity, and it is the only meaningful source of warmth for 1 billion kilometers. On most worlds, a power failure means the lights go out and the air recycling stops, and there is time to fix it. On Titan, a power failure means the building begins losing heat immediately into a dense cold gas that is very good at taking it. The margin between a fault and a frozen habitat is measured in hours, and every reserve system has to be sized against that number rather than against anything else. There is one mercy in all of this, and it is worth naming because it is real. Titan's temperature barely changes. Materials on the Moon endure swings of hundreds of degrees between sunlight and shadow, and that repeated expansion and contraction fatigues them until they fail. On Titan, nothing cycles. Whatever survives the first cooling will keep surviving. It is a harsh environment, but it is an extraordinarily steady one, and steadiness is worth a great deal to anything built to last. Part 4. A shoreline made of the wrong liquid. Titan is the only world besides Earth with stable bodies of liquid standing on its surface. That sentence gets repeated often, and it is worth slowing down on, because the sentence is doing a lot of quiet work. It says liquid. It does not say water. The liquid on Titan is a mixture of methane and ethane, with dissolved nitrogen and a scattering of heavier hydrocarbons. At 94 Kelvin, methane behaves the way water behaves in a temperate climate here. It evaporates. It condenses. It rains. It pools. It flows downhill and cuts channels and fills basins and sits there, flat and still, reflecting the sky. The largest of those basins are near the North Pole. The biggest is a sea covering something on the order of 400,000 square kilometers, larger than the Caspian Sea, which is the largest inland body of water on Earth. Radar mapping shows it to be a complex, branching body with narrow arms reaching far inland, headlands, straits, and a coastline hundreds of kilometers long. The second sea covers roughly 126,000 square kilometers, and has been sounded to depths of about 160 meters. Sounding it at all was an unexpected result. Radar sent down into it passed through the liquid, reflected off the floor, and came back up cleanly, which only happens if the liquid is extremely transparent to radio waves. That in turn means it is extremely pure. Large parts of that sea appear to be close to clean methane, with very little dissolved material to absorb the signal. A third sea sits nearby, and beyond the three of them are hundreds of smaller lakes. Many of those lakes are steep-sided and small, sitting inside raised rims, which is a shape that does not come from flooding a valley. It comes from dissolution, the liquid eating down into the solid ground beneath it and leaving a pit with a lip. On Earth, water does that to limestone and produces sinkholes and karst landscapes. On Titan, methane appears to be doing it to solid organic material, which produces the same forms out of entirely different chemistry. The southern hemisphere has one significant lake and a scattering of dry basins. Why the liquid concentrates so heavily in the north is only partly explained by the seasonal cycle, and it remains one of the open questions about how Titan distributes its weather over long periods. So the shapes are familiar. Now consider what the liquid actually does to anything that enters it. Liquid methane at 94 Kelvin has a density of about 450 kilograms per cubic meter. That is less than half the density of water. A human body, which floats in water only barely, is considerably denser than liquid methane. A person falling into a Titan sea does not bob at the surface and does not float on their back. They sink immediately and without resistance into a fluid that is 180 degrees below freezing. Objects designed to float have to be designed very differently as a result. A hull that would ride high on water sits low in methane, and the low gravity partly compensates but does not cancel the effect. Pressure at depth is also far lower than intuition suggests, because both the density and the gravity are reduced, so the sea floor at 160 meters down is under gentler pressure than a diver experiences a few meters beneath the surface of an Earth lake. Then there is what the liquid does chemically. Methane and ethane are solvents for organic compounds. They do not corrode metal the way salt water does. There is no oxygen and no ionic chemistry to drive that. Instead, they attack the soft parts. Polymers swell and weaken. Plasticizers leach out. Adhesives fail. Seals soften, dissolve, or lose their fit. A Titan sea does not rust a boat. It quietly takes apart everything holding the boat together. And the sea can change beneath a vessel without warning. Nitrogen from the atmosphere dissolves into the liquid, and how much stays in solution depends on temperature and on the ratio of methane to ethane. Shift either one, and the nitrogen comes back out. Bright patches appear on the sea surface over weeks and months, and then vanish again, and the leading explanation is rafts of nitrogen bubbles fizzing out of solution across large areas. A fizzing sea is a genuine hazard. Bubbles reduce the effective density of the liquid, and a vessel sitting in a patch of foaming methane loses buoyancy without anything visibly changing. It is the same mechanism that makes gas seeps dangerous to ships in shallow seas here, operating in a place where no one would think to expect it. Those transient bright patches have been watched carefully enough to earn a nickname among the people studying them. They appear in radar images where there was open sea before, persist for a while, and then are gone by the next pass. Nitrogen fizz is the favored explanation, but suspended solids and floating debris have both been proposed, and there is no way to choose between them from orbit. Whatever they are the only features anywhere in the solar system, outside Earth, that show up on one map of a sea and are missing from the next. The floors of those seas are another quiet surprise. They are unusually smooth and flat, flatter than the floor of any comparable basin on Earth. Either sediment has filled them in over a long time, or the material they are made of does not hold topography well at these temperatures and slowly relaxes into a level surface. Both explanations imply a seabed that would be soft, fine, and deep, which matters enormously to anyone imagining an anchor or a landing. Sending a floating probe to one of those seas has been studied seriously more than once. The engineering problems are always the same three. The cold, which no ordinary mechanism survives. The dissolution of hull materials by the liquid itself. And a sea that can quietly change its density underneath a vessel. Now come back up to the coastline, because the coastline is the part that would trouble a visitor most. Titan's shores look like Earth's shores. There are bays and headlands. There are drowned river valleys, where a channel cut in drier conditions has been flooded and turned into a narrow inlet. There are estuaries. There are islands offshore. There are deltas where rivers meet the seas, branching into the same fanned distributary patterns that rivers make on every coastal plain here, because the physics of a slowing current dropping its sediment does not care what the current is made of. Some of the channels feeding those seas are canyons. One system near the northern seas has walls several hundred meters high, running for tens of kilometers, cut down into water ice bedrock, with liquid methane flowing along the floor at the bottom. It is a river gorge in every structural sense. It was carved by rain, over time, by a fluid running downhill and wearing away rock. The rock is ice, and the rain is fuel, and the result is indistinguishable in shape from a canyon in the American Southwest. Around some of the dry basins there are pale deposits ringing the old shoreline, left behind where liquid evaporated and the dissolved material stayed put. They are evaporites, the direct equivalent of a salt flat made of organic compounds instead of salt. Put all of that together and the landscape reads perfectly to a human eye. Every feature has a name already in the language, and every name is the right one for the shape. And there is nothing there a human body can use. There is no drinkable liquid on the surface of Titan, in any quantity, at any location, at any point in its year. The water is all locked into the ground as a structural mineral. The seas are fuel. The rain is fuel. The rivers carry fuel down to seas of fuel, past beaches of solid organic grains, under a sky full of gas that will not support a flame. It is worth noting the scale of that inventory because it makes the point clearly. Titan's seas contain more hydrocarbon than every proven reserve of oil and natural gas on Earth, many times over. An entire world's worth of chemical energy, sitting in the open, in liquid form, at accessible depth. And not one drop of it can be burned there, because on the whole of Titan, there is nothing to burn it with. The seas are also thought to be layered, with lighter methane sitting over denser ethane at depth, and that layering may overturn from time to time as the surface cools or warms through the long seasons, the same way lakes here turn over in autumn. Waves are small, centimeters rather than meters, because the surface winds are so weak, but in low gravity, on a low-density liquid, the waves that do form move slowly and stand surprisingly tall for the energy in them. Standing on that shore, a visitor would watch a slow, oily swell arriving at a beach in near silence, at about the pace of a hand moving through water. Part 5. Weather made of the wrong fluid. Everything about Titan's seas requires something to keep filling them, and that something is rain. Titan has a complete hydrological cycle. Methane evaporates from the seas and from damp ground. It rises, cools, and condenses into cloud. It falls as rain. It collects into streams, and the streams gather into rivers, and the rivers run downhill through canyons and across plains until they reach the seas, where the whole process begins again. It is the same cycle that keeps this planet green, running on a different molecule at a different temperature, and it is the only other complete cycle of its kind known to exist. The reason it works comes down to a coincidence. Water on Earth sits near its triple point, the narrow set of conditions where a substance can exist as solid, liquid, and gas in the same place. That is why Earth has ice and oceans and clouds all at once. Methane on Titan sits in exactly the same relationship to Titan's temperature and pressure. It is a coincidence with no deeper reason behind it, and it is the entire explanation for why one moon in the outer solar system has weather while all the others have only frost. The clouds form mostly at high latitudes and over the poles, in convective systems that can be hundreds of kilometers across and that build and dissipate over days. Mid-latitude storms are rarer. Equatorial storms are rarer still, and they are the reason the equator looks the way it does. Titan's rain is unlike rain here in almost every respect except its purpose. The drops are large, up to about a centimeter across, several times the size of an ordinary raindrop on Earth. The reason is surface tension and low gravity working together. A drop can grow much bigger before its own weight tears it apart. And once it starts falling, it falls slowly. Terminal velocity for a Titan raindrop is around 1.5 meters per second. A raindrop here reaches something closer to 9. Titan's rain drifts down at about the speed of a snowflake, in drops the size of marbles, through air thick enough to hold them back the whole way. It is also oily. The rain scrubs organic material out of the haze as it falls and carries it down to the ground, and it soaks in. The near-surface material on Titan is therefore damp rather than dry, more like wet sand than like dust, which is one of the few genuinely useful facts anyone has about what it would be like to walk there. But the frequency is the part that would reorganize a settlement's entire way of thinking about time. At Titan's equator, significant rainfall may happen roughly once per Titan year. A Titan year is about 29.5 Earth years. That is not a dry season. That is a drought lasting most of a human working life, ended by a single enormous storm that fills dry channels within hours and sends flash floods down valleys that have been empty since before anyone at the settlement was born. The evidence for those floods is already written into the ground. The channels exist. The canyons exist. The alluvial fans at the mouths of dry valleys exist, spread out exactly as they would be by water on Earth. All of it was cut by rain that nobody has ever observed falling in the low latitudes over timescales long enough that the storms need only be rare, not gentle. Any structure built on an equatorial plain on Titan is built on a floodplain. It will look like a floodplain to anyone who reads the landscape properly, and it will behave like a desert for decades at a stretch, and then one day it will not. At the poles, the situation is different and steadier. Rain there is more frequent, the seas are maintained, and the cycle turns on a shorter loop. That is precisely why the seas are polar. They are where the weather is. The seasons move all of this around the moon on a very long loop. Titan's seasons run about 7.5 Earth years each, inherited directly from Saturn's tilt, and as the sunlight shifts from one hemisphere to the other, the cloud systems migrate with it. The pole that has been in summer slowly cools. The pole that has been in darkness begins to warm. Over a full Titan year, the weather changes hemispheres, and the seas may change level as a result, slowly filling in one hemisphere and drawing down in the other, in a cycle that takes 3 human decades to complete. Near the surface, the atmosphere sits at roughly half of methane saturation at the equator. That is a specific and useful number. It is dry enough that standing liquid at low latitudes evaporates, rather than persisting, which explains the empty channels. It is damp enough that the ground does not dry out entirely, which explains why a warm probe could boil methane out of the soil it landed in. Titan's equator is not a desert in the sense of having no moisture. It is a desert in the sense that the moisture never quite collects. There is one more thing about Titan's methane, and it is the largest unresolved question about the Moon. Sunlight in Titan's upper atmosphere breaks methane molecules apart. The fragments do not simply reassemble into methane. They combine into heavier compounds: ethane, acetylene, propane, hydrogen cyanide, and progressively larger organic molecules, which condense into haze particles and drift down to the surface. Once that happens, the methane is gone from the atmosphere for good. There is no process at the surface that puts it back. The rate at which this happens is well enough understood to estimate how long it takes, and the answer is uncomfortable. All of the methane currently in Titan's atmosphere should be destroyed within something on the order of tens of millions of years. On a planetary timescale, that is very fast. The solar system is 4.5 billion years old. Titan's atmospheric methane is a supply that empties in less than 1% of that. And yet the methane is there right now, in quantity. So one of two things is true. Either something is continuously resupplying it from below, or the atmosphere we observe is a temporary condition that happens to be running during the brief window in which anyone was around to look at it. The proposed sources are all internal. Cryovolcanism could vent methane out of the interior. Methane could be released from clathrate ices in the crust, where it sits, trapped inside a cage of water molecules, until warming lets it go. Or the release could be episodic, tied to cycles of internal heating that turn on and off over millions of years. There are candidate features on Titan's surface that look like cryovolcanic domes and flows. None of them has ever been seen doing anything, and the interpretation remains contested. This is worth sitting with, because it changes the character of everything discussed so far. The atmosphere that gives Titan a survivable pressure, that shields it from radiation, that makes flight possible, that carries the weather and fills the seas. That atmosphere may not be a permanent feature of the Moon. It may be a phase. Titan may spend long stretches of its history as an ordinary airless ice world, with the seas frozen out and the sky gone, and only occasionally put on the version of itself that we happen to be looking at. Nobody knows. It is an open question of the plainest kind, and it is not close to being settled. Meanwhile, the haze keeps falling. Estimates put the production at thousands of tons a year of organic solids raining out of the sky onto the surface, building up sediment layers over geological time. Some of the products of that chemistry condense into clouds in their own right during the long winters. Over one pole, as that hemisphere cooled into its winter, an enormous cloud of hydrogen cyanide ice was observed forming in the stratosphere, a seasonal weather event made of a compound that has no business forming clouds anywhere. And the winds, though weak, are not nothing. Surface winds on Titan usually blow at well under 1 meter per second, which sounds negligible. But the force a wind exerts depends on the density of the air as much as on its speed, and Titan's air is 4 to 5 times denser than ours. A 1 meter per second breeze on Titan pushes about as hard as a wind twice that speed would push here. It is a slow, heavy, persistent kind of air movement, closer to a current in water than to a breeze, and over long enough periods, it is strong enough to build the largest sand features on the Moon. Which is where we turn next. Part 6. Ground made of the wrong solid. Somewhere between a sixth and a fifth of Titan's entire surface is covered in sand dunes. They wrap around the Moon's equatorial belt in long parallel ridges, running for hundreds of kilometers in almost straight lines, standing roughly 100 meters tall, spaced a few kilometers apart. In radar images, they look so much like the linear dune fields of Earth's great deserts that the first people to see them recognized the pattern immediately. The same wind-driven physics has produced the same forms, at the same scale, in the same arrangement, on a moon of Saturn. The sand is not sand. Sand on Earth is mineral, usually quartz, ground down from rock by water and wind over long periods. Titan's dunes are made of solid organic particles that fell out of the atmosphere, the end product of that methane chemistry happening hundreds of kilometers overhead. The grains are around 1/5 of a millimeter across, which is a perfectly ordinary sand grain size. They are dark, and they are much less dense than mineral sand, and they were manufactured in the sky rather than eroded from the ground. They also appear to be sticky. Laboratory work with Titan analogues has shown that organic grains in a dry nitrogen atmosphere hold electrostatic charge for a remarkably long time. On Earth, charge bleeds away quickly through humidity and through the conductivity of the surrounding air. In Titan's conditions, it does not. The grains cling to one another and to everything else, and they stay clung. That has an immediate consequence for the dunes themselves. Charged, cohesive grains resist being moved, which helps explain how such regular structures survive in a place where the surface winds are so weak. It takes a rare, strong storm to move them at all, and the rest of the time they simply hold their shape. It has a much larger consequence for anything mechanical. Lunar dust is a notorious problem, and its problem is abrasion. The grains are sharp, glassy, and unweathered, and they wear out seals and bearings and scratch visors. Titan's dust is a different problem entirely. It is not especially sharp. It is adhesive. It attaches itself to every surface it touches, works into every joint and hinge, coats every lens and window, and does not fall off when brushed. Airlocks, tool handles, boot soles, and camera housings would all accumulate a persistent, dark organic film that gets thicker with every excursion and cannot easily be shaken loose. Now consider what is underneath the dunes, because there the news is more specific. One probe has landed on Titan, and it came down on a plain, not a dune field. What it found was a surface strewn with rounded cobbles of water ice, sitting in a darker, fine-grained matrix. Rounded is the operative word. Those stones were tumbled by a flowing liquid before they came to rest, exactly as river cobbles are rounded here, which means that plain was a streambed at some point in its history. The probe's own landing told the rest of the story. The deceleration trace showed a thin crust giving way under the impact, with softer material beneath it, a surface with a firm skin and a yielding interior. The comparison people reach for is a crust over something damp underneath. It supported the probe. It did not support it rigidly. Damp, cohesive, partly organic ground at 94 Kelvin is not covered by any handbook of soil mechanics ever written. Nobody knows how it behaves under a footing, under repeated loading, under a heated structure, or under a vehicle turning on it. Every assumption about foundations would have to be tested there before it could be trusted. Beneath all of it lies the bedrock, and this is where the last substitution of the surface reveals itself. Titan's bedrock is water ice. At 94 Kelvin, water ice has a compressive strength comparable to many rocks. It is not slippery. It is not soft. It cannot be melted with a warm tool or cut with equipment designed for glaciers. Working Titan's bedrock requires rock-cutting machinery, and the machinery has to function at cryogenic temperature with frozen lubricants and brittle steels. That same bedrock is the only accessible source of oxygen anywhere on the Moon. Follow the chain through, and the shape of the problem becomes clear. Every breath a settlement on Titan takes must be quarried out of frozen ground, hard as stone, and then split apart chemically into hydrogen and oxygen. Splitting water is energy-intensive under any conditions. Here it is happening at the far end of a solar system where sunlight arrives at 1% of its strength at Earth and is then almost entirely absorbed by the haze before it reaches the ground. Meanwhile, fuel is lying on the surface in seas hundreds of kilometers wide, free for the taking in unlimited quantity. That is the complete inversion of every energy problem in human history. Every civilization on this planet has been organized around finding fuel, because oxygen has always been free. On Titan, fuel is free and oxygen is the thing worth mining. A settlement there would measure its wealth in oxidizer, and every calculation about what it could afford to do, how far it could travel, how much it could build, whether it could launch, would come back to how much frozen water it could break apart with the power it had. And below the bedrock there is water after all, in enormous quantity, in the wrong place. Titan has an internal ocean. The evidence comes from how the Moon flexes as it orbits, and from the fact that its rotation is not quite locked as rigidly as a solid body's would be. The crust appears to be floating on something. Best estimates put a liquid layer of water mixed with ammonia beneath an ice shell, perhaps 50 to 100 kilometers thick, with the ammonia acting as antifreeze and keeping the layer liquid at temperatures that would otherwise freeze it solid. That ocean is almost certainly larger than all of Earth's surface water combined. And it may be sealed. Below it, at sufficient pressure, water ice takes on a denser crystalline form, and if that high-pressure ice layer exists on Titan, the ocean sits between two shells of ice with no contact with rock at all. An ocean that never touches a seafloor has no obvious way to acquire minerals or chemical energy, which matters a great deal to any question about what might live in it. So the deepest substitution on Titan is the one nobody standing on the surface would ever notice. There is more water on that moon than on this planet. It is under 100 kilometers of stone-hard ice, mixed with ammonia, possibly sealed away from rock on both sides, and it is the one part of the whole world a visitor could never reach. There are a few other things worth knowing about that surface before we leave it. Titan has almost no craters. A few dozen have been confirmed across an entire moon larger than Mercury, where an airless body of that size would show tens of thousands. Part of the reason is the atmosphere, which destroys small impactors before they reach the ground, so the small craters that pepper every airless world are simply missing. The rest of the reason is erosion. Rain, rivers, wind, and sedimentation are actively resurfacing Titan, filling craters in and wearing their rims down, and possibly cryovolcanism is helping. Titan's surface is young, and it is young because it is alive in the geological sense. The bright highland terrain near the equator, standing above the dark sand seas, appears to be older water ice crust, heavily dissected by channels and worn down over long periods. The dark lowlands are where the organic sand collects. Between them, the moon divides into two entirely different landscapes, with very little overlap, and where a settlement sits determines almost everything about what it deals with. A polar base has seas and rain and a shorter weather cycle. An equatorial base has dunes and decades of drought and a flood risk it will not see coming. There is also a small mystery in the sand itself. The dunes appear to migrate eastward, which is the opposite of the direction the weak prevailing surface winds normally blow. The resolution seems to be that the ordinary winds do not move the sand at all. The rare, strong storm winds do all the work, and they blow the other way. A landscape shaped almost entirely by events that hardly ever happen is a fair summary of Titan generally. We are halfway through now, and it is worth gathering what we have. A moon larger than Mercury, with a nitrogen sky at comfortable pressure and no oxygen in it. Cold so deep and so dense that heat is pulled out of anything warm faster than a vacuum could manage. Seas of liquid fuel, with coastlines and deltas and canyons carved by fuel-bearing rain that falls once a generation. Beaches of manufactured organic sand that clings to everything it touches. Bedrock of ice as hard as stone, holding all the oxygen there is. 6 familiar things, 6 substitutions, and we have not yet looked up. Part 7. Daylight that never quite arrives. Saturn receives about 1% of the sunlight Earth receives. That is the starting point, and by itself it is not disqualifying. 1% of a very bright thing is still a usable amount of light. Then Titan's haze goes to work on it. The haze is the accumulated product of methane chemistry, layer upon layer of fine organic particles suspended through hundreds of kilometers of atmosphere, produced continuously above and settling slowly below. It is what makes Titan orange from outside. From underneath, it is what makes Titan dim. By the time sunlight reaches Titan's surface, it has been reduced to something on the order of 1/1000th of Earth's daylight. The comparison people reach for is standing outdoors here about 10 minutes after the sun has gone down, under heavy overcast. That is roughly the light level. Permanently. In every direction. At every hour of every day of a year that lasts 3 decades. It is bright enough to see by. That should be said clearly, because it is easy to imagine Titan as a dark world, and it is not. 1/1000th of daylight is still around 1,000 times brighter than a full moon night on Earth. A person outdoors on Titan, after their eyes adapted, could read by the ambient light. They would see the landscape in detail. It is not darkness. It is a permanent, even, uniform dusk. Uniform is the important word. The haze scatters light so thoroughly that it arrives from every part of the sky at once. There is no visible sun, no disk, no beam, no direction. And where there is no directional light, there are no shadows. A landscape without shadows is a landscape without depth. Almost everything the human eye uses to judge relief, the shading on a slope, the dark line at the base of a boulder, the way a hollow fills with shade, depends on light arriving from one direction. Remove that, and a scene becomes flat. The images sent back from Titan's surface are sharp, detailed, and remarkably hard to read for elevation. A ridge and a stain on the ground can look identical. A drop-off can be invisible until it is stepped into. For anyone walking on Titan, that would be the daily hazard. Not the cold, which is managed by the suit. Not the atmosphere, which is managed by the mask. The ground, which cannot be read. The lighting also settles the question of power, permanently. Even ignoring the haze, 1% of Earth's sunlight makes solar panels marginal at Saturn. After the haze removes almost all of the rest, a solar array on Titan's surface would have to be preposterously large to run anything at all. Solar power is not a difficult option there. It is not an option. Every settlement in the Saturn system runs on nuclear fission, or it does not run. Then there is time, which Titan handles strangely. Titan is tidally locked to Saturn. Its rotation period and its orbital period are identical, about 15 days and 16 hours. A Titan day and a Titan month are the same interval, and one face of the Moon is turned toward Saturn permanently. But that 16-day cycle barely announces itself at ground level. The change in illumination between local day and local night is small compared to the overall dimness. The sky goes from very dim to somewhat dimmer, and back. There is no sunrise. There is no sunset. There is no shadow lengthening across a plain in the evening, because there are no shadows and there is no evening. The year is 29.5 Earth years, and the seasons are about 7.5 years each. Someone posted to Titan for a decade would experience a little more than one season. The weather they arrived in would be, for practical purposes, the weather. Human circadian rhythm has nothing to attach to in an environment like that. There is no natural cue of any kind, no dawn, no dusk, no noon, no gradient of brightness across the day. The body's clock, left alone, drifts. So every settlement would run on an imported 24-hour cycle maintained entirely by artificial lighting, and the world outside would neither support that clock nor contradict it. It would simply be indifferent to it, looking exactly the same at every hour anyone chose to call morning. The color is the last surprise. The haze filters blue light out of the spectrum almost completely before it reaches the ground. What arrives is orange and dull red. Everything on Titan's surface, the ice cobbles, the organic sand, the seas, the sky, the suit, the hands in front of a visor, would be some shade of orange-brown. Not as a matter of atmosphere or mood, but as a matter of physics. There is no other color available. There is a way around some of this, and it is the reason Titan was mapped at all. The haze is far more transparent at infrared wavelengths than at visible ones. Certain narrow windows in the infrared spectrum pass through it almost cleanly, and everything known about Titan's surface geography was assembled by looking through those windows, along with radar. A settlement on Titan would see its own world in false color by necessity. The cameras that worked would be infrared cameras, and the images on every screen would be renderings of a landscape no human eye could resolve directly. The haze itself is layered rather than uniform. There are distinct hazes at different altitudes, including detached layers hundreds of kilometers up, which is why Titan, seen from outside, has a soft double edge rather than a clean limb. And over whichever pole is in winter, the haze thickens into a darker cap that persists through the cold season and then dissipates as the light returns. That slow migration of the polar hood is one of the very few visible indications from outside that time is passing on Titan at all. And then there is the thing that is not in the sky, which is the strangest fact in this part of the episode. From the surface of Titan, Saturn is invisible. Saturn is right there. It is 1.25 million kilometers away, which is only about 3 times the distance from Earth to the Moon. It subtends roughly 5.5 degrees of sky, about 11 times the width of the full moon as seen from here. It is the largest object in anyone's sky anywhere in the solar system, and it hangs motionless at a fixed point, because Titan's locked rotation means Saturn never rises and never sets. From half of Titan, it would always be overhead. From the other half, it would never be visible at all. And through the haze, none of it can be seen. Not the disk, not the bands, not the shadow it casts, not the rings. A visitor could spend their entire posting on Titan and never once see the planet they were orbiting. The rings are a further disappointment on top of that one. Titan's orbit is inclined to Saturn's ring plane by only about 1/3 of a degree, which means that even from above the haze, the rings would present themselves almost exactly edge-on. Not a broad set of arcs. A thin, bright line drawn across the sky, a few tens of meters thick and 250,000 kilometers wide, seen from within its own plane. Every major moon of Saturn has this problem, because almost all of them orbit in the ring plane. The image everyone carries of Saturn, hanging enormous and ringed above an icy landscape, is, for practically every world in the system, wrong. There is exactly one exception, and we will get to it. The last thing missing from Titan's sky is a direction. Titan has no intrinsic magnetic field. It generates nothing of its own. What it has is a weak induced field, produced where Saturn's magnetosphere flows around Titan's ionosphere, and that field is variable, complicated, and useless for orientation. A magnetic compass on Titan does nothing dependable. There are no stars, because the haze blocks them. There is no sun to take a bearing from. There is no planet in the sky. There is no shadow to read the hour off. There is not even a reliable horizon, because the dense atmosphere refracts light strongly near the ground, and the visible horizon is displaced and appears to curve slightly upward, which makes distances hard to judge as well as directions. So a person standing on Titan, in an atmosphere at a comfortable pressure, in adequate light, on solid ground, would have no natural way of knowing which way they were facing or how far away anything was. Every method of navigation would have to be brought with them: inertial systems, radio beacons, an orbiting satellite network, and all of that infrastructure would have to be built and maintained before anyone could safely walk further than they could see. Which is a fair summary of the moon as a whole. Everything a body needs is present, and none of it works. Part 8. The ocean that comes to you. Titan is the moon with the sky. Enceladus is the moon with the ocean, and it is the more remarkable of the two by a considerable margin. Enceladus is small. It measures about 500 kilometers across, which is roughly the width of the state of Arizona, and its mass is about 1/700th of Earth's. Its surface gravity is around 1/100th of a gravity. Its escape velocity is about 240 meters per second, which is fast for a thrown object and slow for a rocket. It is also the most reflective body known anywhere in the solar system. Its albedo runs close to 90%. It sends back almost all the light that falls on it. That is why it is so cold. A surface that absorbs nothing stays at the temperature of its surroundings, and the surroundings out there are around 75 Kelvin, dropping into the 30s in ground that has never seen the sun. And across its southern polar region run 4 long parallel fractures. Each is about 130 kilometers long, 2 kilometers wide, and half a kilometer deep. They cut across the terrain in near parallel lines, and they are warm. Along their length, more than 100 separate jets are venting continuously into space. That is the sentence worth sitting with. A moon the size of a small country is spraying its own ocean into orbit, without pause, and has been doing so for as long as anyone has been able to look. The jets carry water vapor and fine ice grains outward at speeds around 400 meters per second. That is well above the escape velocity, which means most of the material never comes back down. The output runs at something like 200 kilograms every second, continuously, and it has to be replaced from below. What happens to all that material is one of the most elegant connections in the solar system. It goes into orbit around Saturn and spreads out into a ring, the broadest and faintest of Saturn's rings, extending across hundreds of thousands of kilometers. A moon 500 kilometers wide is single-handedly maintaining a structure larger than the main ring system, out of its own interior, one jet at a time. Now consider what is in the material, because this is where Enceladus stops being merely unusual. The plume contains water, carbon dioxide, methane, ammonia, molecular hydrogen, salts, silica grains, and complex organic molecules, some of them large macromolecular fragments. The molecular hydrogen is the important one. Hydrogen in that setting is produced when hot water reacts chemically with rock. Its continuous presence in the plume means that reaction is happening right now, on the floor of the ocean, at temperatures probably above 90 degrees on the Celsius scale. Enceladus has hydrothermal activity. The silica grains point the same way. Silica dissolves into water at high temperature and precipitates out as fine particles when that water cools and mixes. The grains found in the plume are exactly the size and composition that process produces, and it does not happen in cold water. The salts show the ocean is in prolonged contact with rock and has dissolved minerals out of it, at a concentration broadly comparable to Earth's oceans by some estimates. And phosphates have been identified in the ejected material. Phosphorus is one of the elements every known form of life requires, and it is the one most often in short supply in natural waters. Finding it dissolved in quantity in an alien ocean is a substantial result by any measure. Put it together: liquid water, rock contact, heat, salts, organic chemistry, phosphorus, and hydrogen together with carbon dioxide, which is a usable chemical energy source. On Earth, entire microbial communities live on precisely that reaction, taking hydrogen and carbon dioxide and producing methane, and needing no sunlight to do it. Enceladus has every ingredient anyone has ever listed, and it is delivering samples to anything that flies past. Beneath the ice, the ocean is global rather than local. The evidence comes from how the moon rocks slightly as it orbits, a wobble too large for a body frozen solid all the way through. The crust has to be decoupled from the interior by a liquid layer. The ice shell averages perhaps 20 to 25 kilometers thick over most of the moon, but thins to a few kilometers at the South Pole, which is why the fractures reach through there and nowhere else. The ocean beneath is on the order of 10 kilometers deep under the pole and thicker elsewhere, and it sits directly on a porous rocky core. The heat that keeps it liquid comes from tides. Enceladus is locked in a 2-to-1 orbital resonance with the larger moon Dione, and that resonance keeps its orbit slightly elliptical. An elliptical orbit means the strength of Saturn's pull rises and falls over each circuit, so the moon is continuously flexed and released. That flexing heats the interior. Without Dione holding the orbit out of round, Enceladus would freeze solid, and the ocean would be gone. So the most promising place in the outer solar system exists because of the orbital arrangement of the neighbor beside it. That same flexing shows up in the output of the jets. The plume is not steady. It strengthens when Enceladus is furthest from Saturn and the fractures are pulled open, and it weakens when the moon is closest and the fractures are squeezed shut. The whole system breathes on a cycle of about 1 1/3 days, which is the length of the moon's orbit. It is the slowest and most regular respiration in the solar system, and it has probably been running for a very long time. There is more heat coming out of that south polar region than tidal models comfortably account for. The measured output exceeds the predictions by enough that something in the picture is incomplete. Either the interior is more dissipative than assumed, or the activity is running in bursts and this is a strong period, or the resonance with Dione has been doing more work recently than it does on average. It is another open question, and it bears directly on whether Enceladus has been this active for billions of years, or only for a fraction of that. The two hemispheres tell that story from opposite ends. The South Polar terrain is geologically young, smooth, and almost entirely without craters, resurfaced over and over by the activity beneath it. The Northern Hemisphere is ancient, heavily cratered, and undisturbed. One small moon carries two entirely different geological histories on its two halves, and the boundary between them is where the heat is. And now the substitution, which in this case is the deepest one in the episode. Enceladus offers something no other world offers. It hands over ocean samples in orbit, free, without drilling, without landing, without any of the difficulty that makes subsurface oceans elsewhere effectively unreachable. It is the single most accessible alien ocean anyone will ever have. And it is the world where a human presence makes the least sense of anywhere in the system. Start with standing on it. The South Polar terrain is the interesting ground, and standing there means standing beside a supersonic jet of ice crystals venting into near vacuum on a surface fractured by the same forces driving the jets, in ground that is actively coming apart. Then there is the gravity, which is not a difficulty so much as an incompatibility. 1/100th of a gravity is not low gravity in the way the moon has low gravity. A normal walking push-off, the ordinary force a leg applies to take a step, would launch a person tens of meters upward and leave them traveling on a ballistic arc for minutes at a time. Nothing can be poured. Nothing settles. A dropped tool takes an extraordinarily long time to arrive anywhere. Dust raised by a footfall does not fall back. It drifts, or it leaves entirely. The snow makes all of it worse. Material from the ring falls back onto Enceladus continuously, building deposits of ice powder with grain sizes around a micron, finer than talc, finer than anything on any other surface known. In places it is meters deep. It has essentially no load-bearing strength. It hides the terrain completely, and in that gravity it would billow away from any disturbance and stay suspended. And then the last problem, which is not engineering at all. Enceladus may hold life. Not as a hopeful phrase, as a genuinely open scientific question, with the chemistry, the energy, the water, and the time all accounted for. And a world that may hold life is a world that a visitor can ruin simply by arriving. Terrestrial microorganisms carried in on a hull would find, at the bottom of those vents, conditions not unlike the ones some of them already live in on Earth. The contamination runs in both directions, too. An ocean of unknown biology is not a substance anyone brings inside a habitat casually. So the most inviting thing in the Saturn system is the thing that argues hardest for keeping human beings away from it. Enceladus offers its ocean freely, and the correct response to that offer, at least for now, is to take the sample and stay out. Part 9. Ground that will not hold. Every habitat needs one thing before it needs anything else. It needs to be attached to something. Foundations, anchors, landing legs, drill casings, all of it assumes a ground that stays where it is put and holds what is put on it. That assumption is where several of Saturn's moons quietly fail. Begin with Mimas, which is the smallest body in the solar system that its own gravity has pulled into a sphere. It measures about 400 kilometers across, and it is dominated by a single feature. The crater is about 130 kilometers wide. That is a third of the entire diameter of the Moon. Its walls stand 5 kilometers high, its floor lies 10 kilometers below the rim, and a central peak rises 6 kilometers from that floor. Standing on the crater floor, the far wall would be below the horizon, and the peak in the middle would be a mountain taller than anything in the Alps, rising out of a plain of ice. The impact that produced it very nearly destroyed the Moon. On the opposite side of Mimas, There are fracture patterns that appear to have been produced by the shock wave traveling through the body and converging on the far side. A slightly larger impactor or a slightly faster one, and Mimas would be a debris field. Its density is about 1.15 grams per cubic centimeter, which means Mimas is almost entirely water ice, with only a small fraction of rock. It is a frozen ball, ancient, saturated with craters, showing no sign of ever having done anything. And underneath that surface, careful measurement of the way Mimas rocks back and forth in its orbit points to a liquid ocean 20 to 30 kilometers down. That result is genuinely difficult to accept, and it took a long time to be taken seriously, because Mimas has none of the surface features an ocean world is supposed to have. There are no fractures venting anything. There are no smooth resurfaced plains. There is no thermal anomaly. Enceladus, next door, advertises its ocean constantly. Mimas advertises nothing at all. The current explanation is that the ocean is young. Geologically recent, perhaps only a few million to a few tens of millions of years old, which is far too little time for the surface to have registered it. The heat has not yet worked its way up. The crust has not yet cracked. Mimas is an ocean world that has not started looking like one. The lesson from that is worth carrying through the rest of this episode, because it applies everywhere. A surface tells you almost nothing about what is beneath it. Every judgment about which ground in this system is stable and what lies under a proposed landing site is a judgment being made with no data at all about the part that matters. Mimas has two other peculiarities worth a moment. The first is a temperature map that makes no sense at first sight. Instead of the smooth gradient from warm equator to cold pole that a simple body should show, one hemisphere carries a sharp-edged cooler region with a rounded outline and a wedge missing from it, as though something had taken a bite out of a disk. The explanation is that high-energy electrons sweeping past Mimas strike one hemisphere preferentially and sinter the ice there, packing the grains together and turning that region into a better conductor of heat. The pattern is not a shadow or a coating. It is a change in the physical texture of the ice, drawn across a moon by particles. The second is that Mimas, for all its smallness, is holding the rings in place. It orbits at a distance where ring particles in a particular band complete 2 orbits for every one of Mimas's, and that repetition builds up until those particles are cleared out entirely. The widest visible gap in Saturn's rings, the one anyone can see through a small telescope, is maintained by the gravity of a 400-kilometer ball of ice with a hole punched in it. Then there is Hyperion, which barely qualifies as ground in the first place. Hyperion measures about 270 kilometers along its longest axis and is not remotely round. Its surface is covered in deep, sharp-edged pits, giving it an appearance closer to a sponge than to a moon. That appearance is not a coincidence of lighting. It reflects what the body is made of. Hyperion's density is about 0.54 grams per cubic centimeter. More than 40% of its volume is empty space. It is not a solid object with holes in it. It is a loosely bound pile of ice fragments that has never been compacted, held together by a gravity too weak to compact it. Landing on it, in the ordinary sense, is not something that can happen. There is no bearing surface to land on. A vehicle touching down would either sink into the porous material or rebound off it, and the rebound is the more troubling case, because Hyperion's escape velocity is under 100 meters per second. A bounce could easily exceed it. Arriving at Hyperion too firmly means leaving Hyperion. It also tumbles. Hyperion's rotation is chaotic in the technical sense, not merely irregular but genuinely unpredictable beyond a short horizon, because its odd shape and its orbital resonance with Titan combine to make its spin mathematically unstable. It has no fixed day. It has no fixed pole. Its orientation an hour from now can be calculated. Its orientation a month from now cannot. And its surface carries a static electric charge. A spacecraft passing nearby registered a beam of electrons flowing off the Moon across several thousand kilometers of space. That is not a subtle effect. Anything approaching Hyperion is entering an electrostatic environment as much as a gravitational one, and any object that touched down would find itself part of a circuit it did not design. The mid-sized icy moons are steadier than that, but they carry their own version of the same problem. Tethys is about 1,060 kilometers across, with a density of roughly 0.98 grams per cubic centimeter. That number is remarkable in an understated way. It means Tethys is so close to pure water ice, with almost no rock in it at all, that if a body of water large enough existed, Tethys would float in it. Across that moon runs a canyon system around 2,000 kilometers long, up to 100 kilometers wide and 3 to 5 kilometers deep. It wraps most of the way around the body. It is thought to be a fracture from the Moon's interior freezing and expanding, which is what water does when it freezes, on a scale where the expansion cracks a world open. Tethys also carries an impact crater about 450 kilometers wide, close to 2/5 of its own diameter. Its floor has relaxed and flattened over time, which tells us the ice flowed after the impact, slowly, the way a glacier flows, over a very long period. The ground on these moons is not permanent, even where it looks it. Dione, about 1,100 kilometers across, shows bright streaks across its trailing hemisphere that were long assumed to be frost. At high resolution, they resolve into something better, networks of ice cliffs, hundreds of meters high, running for hundreds of kilometers. They are fault scarps, the Moon's crust broken and displaced. Dione also shows hints of a subsurface ocean of its own, deep beneath a thick shell, which would bring the count of ocean worlds in this one system to 4 or more. Rhea is the second largest of Saturn's moons at about 1,500 kilometers across, and it holds one detail worth reporting for the way it sounds against the way it is. Rhea has an atmosphere of oxygen and carbon dioxide, produced by radiation splitting the water ice on its surface. It is oxygen, genuinely, permanently maintained, and it is roughly 100 trillion times thinner than the air in this room. It is a laboratory vacuum that happens to have a name. It is the closest thing to breathable air on any moon in the system apart from Titan, and it is nothing at all. There is one more feature of this family that is easy to miss and pleasant to know. Several of these moons have companions of their own, tiny bodies locked at the stable points 60 degrees ahead of and behind them in their orbits. Tethys has 2. Dione has 2. They are moons orbiting a planet while holding formation with a larger moon, a configuration seen nowhere else in the solar system, keeping station for the entire age of the system without drifting. Part 10. A horizon with a wall across it. Far out beyond the mid-sized icy moons, on a slow 79-day orbit about 3.5 million kilometers from Saturn, sits the strangest large body in the system. Iapetus is about 1,470 kilometers across, which makes it the third largest of Saturn's moons. It is also, by a wide margin, the one that raises the most questions per square kilometer. Start with what anyone would notice first. One hemisphere of Iapetus is as dark as coal, reflecting about 5% of the light that falls on it. The other is as bright as dirty snow, reflecting somewhere between 50 and 60%. Those two figures describe the same object. The difference between the halves is more than a factor of 10, and the transition between them is not the gentle gradient that most planetary boundaries turn out to be on close inspection. The explanation, once it was worked out, is a runaway process, and runaway processes are always worth attention because they explain how small differences become permanent ones. Dark dust drifts inward through the outer Saturn system and settles preferentially on the hemisphere Iapetus leads with as it orbits, the same way rain collects on a car's windscreen and not its rear window. Dark material absorbs more sunlight than bright material. Absorbing more sunlight makes it warmer. Warmer ice sublimates, turns directly from solid to vapor, and that vapor migrates and recondenses on the coldest surface available, which is the bright hemisphere on the other side. So the dark side loses its ice and becomes darker and drier. The bright side gains that ice and becomes brighter and colder. Each step makes the next step easier. Once the process starts, it cannot stop, and it has been running for a very long time. The temperature difference is measurable. The dark hemisphere reaches about 130 Kelvin, which is the warmest surface temperature anywhere in the Saturnian moon system. The bright hemisphere sits nearer 100. Two halves of a single body, thermally distinct, permanently. And the coating is thin, perhaps tens of centimeters deep, over bright ice underneath. Iapetus is not a dark moon. It is a bright moon that has been painted, and the paint is still being applied. At small scales, the boundary between the two hemispheres is not a boundary at all. It is a patchwork. Dark material collects on the sun-facing walls of craters, where the warming is strongest, while ice survives on the shaded walls just meters away. So the transition zone is a landscape of alternating black and white slopes, arranged by which direction each surface happens to face, and the pattern gets finer the closer anyone looks. It is one of the few places in the solar system where the difference between two adjacent square meters of ground is a difference in color so extreme it can be seen from another planet. Iapetus does nothing else. It has no internal activity worth the name, no measurable heat flow, no resurfacing, no evidence of an ocean, no cryovolcanism. It is one of the most thoroughly frozen large bodies anywhere, and it has probably been geologically static for billions of years. Everything happening to Iapetus is happening to it from outside. Then there is the ridge, which is the feature that no one has explained. Along a large fraction of Iapetus's equator runs a mountain range more than 1,300 kilometers long, up to 20 kilometers high, and about 20 kilometers wide at its base. It follows the equator closely enough that the alignment cannot be an accident. From orbit it looks like a seam, as though the moon had been assembled in two halves and the join left proud. 20 kilometers is more than twice the height of the tallest mountain on Earth, measured from sea level. On a body less than a fifth of Earth's diameter, relative to the size of the world it sits on, it is the largest mountain structure known anywhere in the solar system. Nobody knows what built it. There are three families of explanation, and none has won. The first proposes that Iapetus once had a ring of its own, debris from a collision, orbiting the moon, which decayed and fell, depositing its material along the equator in a line. That would explain the alignment perfectly, and requires a sequence of events nobody has evidence for. The second proposes that the ridge is a fossil of a much faster early rotation. Iapetus does have an equatorial bulge appropriate to a spin period of about 16 hours, and it now turns once every 79 days. Its shape is left over from an earlier era, frozen in place because the crust hardened before the body could relax into the rounder form its current spin would produce. A ridge could be part of that same frozen inheritance. The third proposes crustal buckling as the moon cooled and contracted, with the compression concentrating along the equator. All three are plausible. None is demonstrated. The largest mountain range in the solar system, by relative measure, sits on a moon of Saturn without an accepted origin. For a visitor, the practical facts are simpler than the theory. There is a wall across the horizon that no vehicle drives over. Half the moon is dark and warmer and dry. The other half is bright and colder and icy. And crossing between them means crossing the ridge or going round it. But Iapetus earns its place in this episode for one more reason, and it is the pleasant one. Almost every major moon of Saturn orbits in the ring plane. That was said earlier about Titan, and it is true of nearly all of them. From their surfaces, the rings appear edge-on, a line, not a disk. The famous image of Saturn hanging enormous and ringed over an icy landscape is, for practically every world in that system, simply not available. Iapetus is the exception. Its orbit is inclined about 15 degrees to the ring plane, which is enough. From Iapetus, the rings open into a visible ellipse. Saturn appears roughly 2 degrees across, about 4 times the width of the full moon from Earth, hanging small and pale and unmistakably ringed against a black sky full of stars, in an atmosphere-free vacuum where nothing blurs the view. It is the best view in the solar system. And it sits on a moon with a hemisphere of dark dust, a 20-kilometer wall across its equator, no internal activity, no accessible water beyond frozen ice, and nothing else whatsoever to recommend it. The one place with the view is the one place with the least reason to be. There is a final piece to the Iapetus story, and it involves an object almost nobody thinks about. Phoebe orbits Saturn about 13 million kilometers out, traveling backwards relative to nearly everything else in the system, on a steeply tilted path. It is dark, roughly 213 kilometers across, and its surface composition resembles the icy bodies of the outer solar system rather than anything else at Saturn. It was almost certainly captured rather than formed there, a piece of the outer solar system that wandered too close and stayed. Micrometeorites hitting Phoebe knock dust off its surface, and that dust spreads into a ring. Not a visible one. This ring extends from roughly 130 to more than 200 Saturn radii, tilted well out of the main ring plane, and it is the largest ring structure known around any planet. It is also so tenuous that a spacecraft flying directly through it would register almost nothing at all. It cannot be seen from inside itself. It was only detected by looking for its faint infrared glow from a great distance. And that invisible ring is the source of the dark material painting Iapetus. Its particles orbit backwards, so they meet Iapetus's leading hemisphere head-on at very high relative speed, which is why the coating process works as efficiently as it does. Phoebe is not alone out there either. Saturn holds dozens of small irregular moons on distant, inclined, mostly backwards orbits, and they cluster into families that share orbital properties. Each family looks like the debris of a single captured object that was broken apart long ago, and the pieces have been traveling together ever since. The outer Saturn system is therefore not a collection of individual strays. It is a set of scattered inheritances, each one the remains of something that arrived whole. So a small, captured body, sitting out in the dark on a backwards orbit, is quietly repainting a moon 1,000 kilometers wide, and the mechanism that connects them is a structure larger than any other ring in the solar system that no eye could ever detect. That is the Saturn system in miniature. Everything is doing something to everything else, slowly, and almost none of it is visible. Part 11. The flaw that was never there. There is one more thing in the Saturn system that looks like a place, and it is the most convincing of all of them. Saturn's main rings span roughly 280,000 kilometers from the inner edge to the outer. That is most of the distance from Earth to the Moon, laid out flat in a single continuous sheet. Seen from a distance, they look like a surface. They look, more than anything else in the outer solar system, like ground. Their average thickness is somewhere on the order of 10 to 30 meters. Those two numbers belong in the same sentence as often as possible, because the ratio between them is difficult to hold in the mind. A structure 250,000 kilometers wide and about as thick as a 5-story building. Shrink the rings down to the size of a football pitch, and they would be far thinner than a sheet of paper. There is no other object in the solar system with proportions remotely like that. And they are not solid. The rings are made of individual particles, more than 95% water ice, ranging from grains of dust up to boulders the size of a house. Every one of those particles is on its own independent orbit around Saturn, obeying the same laws that hold a moon in place, taking anywhere from a few hours to more than half a day to go round. They are bright because they are ice, and because something is keeping them clean. Dark dust drifts continuously into the Saturn system from outside, and over the age of the solar system, it should have darkened the rings considerably. It has not. That relative cleanliness is one of the main arguments that the rings are young, possibly only tens to a few 100 million years old, which would make Saturn's rings a more recent feature than a good many things on Earth's surface. Now to the substitution, which here is total. Standing on the rings is not a thing that can happen, and the reason is not engineering. It is orbital mechanics. Every ring particle is in free fall around Saturn. Free fall is weightlessness. There is no downward direction inside the rings, no surface pressing back, no support of any kind. A person placed among the particles would float among them, in the same orbit, feeling nothing. It gets less accommodating from there. Particles at different distances from Saturn orbit at different speeds. Closer means faster, as it does everywhere. Two objects separated by 100 meters in radius do not stay 100 meters apart. They drift steadily past one another and keep drifting permanently. Anything spanning even a small radial distance is being sheared by orbital motion itself, and no structure can be built across that shear without fighting it continuously. The collisions between particles are frequent and extremely gentle. Relative speeds are centimeters per second, a slow nudge rather than an impact. And that gentleness is precisely why the rings are so flat. Every particle that acquires some up and down motion eventually bumps into another and loses it. Over enough time, all the vertical motion is damped away, and what remains is a sheet, flattened by nothing more than an endless series of very soft collisions. A visitor inside the rings would not see a ring at all. At close range, the particles are separated by many times their own diameters. It would look like a sparse field of slowly tumbling ice, drifting past at walking pace, with the plane apparent only because it stretches away in two directions to a horizon that never curves. The most solid-looking structure in the solar system, from within, is mostly empty space. The particles themselves are not evenly assorted. There are far more small ones than large ones, following a distribution that keeps most of the surface area in grains and most of the mass in the bigger pieces. Many of the larger bodies are not solid at all, but loose aggregates, clumps held together weakly, forming and dispersing as they jostle past one another. In parts of the rings, a given lump may assemble and come apart repeatedly over the course of a single orbit. The rings are less a collection of objects than an ongoing process of objects nearly forming. There are, however, moons living inside it, and they do something worth describing. Small moons orbit within the ring system and carve gaps in it. One sits inside a gap near the outer edge of the main rings and holds it open by clearing material along its path. Another, smaller still, occupies a narrower gap further out. Both have been shaped by their surroundings. They have swept up ring material along their own equators as they plow through, and the accumulated matter has built distinct equatorial ridges, giving them flattened shapes with a raised band around the middle. They look like they were turned on a lathe, and in a sense they were. The ring did the turning. The moon in the narrow outer gap is massive enough to raise waves in the edges of that gap standing more than a kilometer high. That is a genuinely difficult thing to picture. Vertical structures more than a kilometer tall, raised in a sheet that is only tens of meters thick, held up by the gravity of a moon 8 kilometers across passing by. Further out, a pair of shepherd moons on either side of a narrow ring confine it between them, keeping a ribbon of material in place that would otherwise spread out and disperse in a geologically trivial amount of time. The rings are also full of structures that betray things too small to see. Spiral density waves propagate outward through the sheet, driven by resonances with the larger moons, and reading those waves allows the ring's own mass to be measured. Propeller-shaped disturbances mark the positions of moonlets embedded in the material, too small to image directly, but large enough to disturb what surrounds them. And there are waves in the rings raised by oscillations inside Saturn itself, which means the ring system functions as a seismograph, recording the interior of a planet that has no surface to put an instrument on. The gaps deserve a correction as well, because they are not what they appear to be. The widest and most famous of them, the one visible through a small telescope from a back garden on Earth, is not empty. It contains sparse material of its own, thin enough to look black at a distance and quite definitely there up close. It is a region of reduced density maintained by a resonance, not a hole. And one of the outer rings behaves in a way none of the others do. It is narrow, braided, clumpy, and visibly different from one month to the next, knots forming and dispersing, strands crossing over each other, structures appearing where there was nothing before. Shepherd moons on either side are stirring it constantly. Of everything in the Saturn system, it is the feature that changes fastest, and it is the closest thing the rings have to weather. And then the last fact, which is the one that changes the character of the whole structure. The rings are falling into Saturn. Charged ring particles are captured by Saturn's magnetic field and pulled down along the field lines into the planet's upper atmosphere. The infall is continuous, and the measured rate is substantial, hundreds to thousands of kilograms every second, arriving as a steady drizzle of ice into a sky that has no floor to catch it. Where it lands, it alters the chemistry of Saturn's ionosphere and produces dark bands in the upper atmosphere, aligned with the ring structure above. At that rate, the rings are losing mass on a timescale on the order of 100 million years or less. They are also spreading, inward and outward, under their own internal dynamics, and the inner edge is being eroded from below. The conclusion most models reach is that Saturn's rings are temporary. They were probably not there when the first complex life appeared on Earth. They will probably not be there when the sun begins to swell at the end of its ordinary life. What everyone thinks of as the permanent, defining feature of the sixth planet, the thing that makes it recognizable in any illustration ever drawn, is a passing condition, and it is measurably ending. There is even a reasonable chance the rings were made by a loss. One serious proposal is that an icy moon wandered too close to Saturn, crossed the distance at which tidal forces exceed a body's own gravity, and was pulled apart into the sheet that now surrounds the planet. If that is right, then the most beautiful structure in the solar system is the remains of a world that did not survive, spread thin and slowly coming down. Part 12. What the distance actually costs. Everything discussed tonight has been about materials and environments. There is one more constraint on living in the Saturn system, and it has nothing to do with any of the moons. It is the distance itself, and it is the only one of these problems that no engineering can reduce. Radio takes about 80 minutes to travel from Saturn to Earth. Any exchange requires 2 hours and 40 minutes at an absolute minimum, and that is before anyone reads the message, considers it, consults a colleague, or writes a reply. No emergency at Saturn can be managed from Earth. There is no talking a crew through a failure while it happens. There is no watching a landing and calling out a correction. Every decision that matters is made locally, by whoever is present, with whatever information they have at that moment, and Earth learns about it afterward the way one learns about weather in another country. The transit compounds it. A practical crewed transfer to the Saturn system takes on the order of 6 to 7 years using gravity assists, and the launch windows are set by planetary alignment rather than by anyone's schedule. They come when they come. So there is no rescue. That is not a dramatic claim, it is an arithmetic one. A relief mission departing the instant a problem became known on Earth would arrive most of a decade later, having been assembled and launched in the meantime. A settlement in the Saturn system is on its own in a way that no expedition in human history has ever been, including the ones that went to places nobody came back from. The bandwidth is thin as well as slow. Signal strength falls with the square of distance, so a link from Saturn carries far less data per second than a link from Mars, on top of the delay. Whatever a settlement sends home would be a compressed summary, arriving late. Power has already been settled in the earlier parts, but it is worth stating in one place. Solar energy at Saturn arrives at about 1% of its strength at Earth, and on Titan's surface, after the haze, at a small fraction of that again. Nuclear fission is not the preferred option. It is the only option on every world in the system, permanently. And on Titan, that reactor is doing 2 jobs. It supplies power, and it is the only source of heat in an environment that pulls heat out of a warm structure faster than vacuum ever could. A power failure elsewhere in the solar system means the lights go out. A power failure on Titan means the building starts cooling toward 94 Kelvin immediately, in a dense cold gas, very good at taking warmth away. The propellant situation is the same inversion in a different form. Methane on Titan is free, unlimited, and lying on the surface in seas. Oxygen is not available in any form and must be extracted from ice as hard as rock, using energy at cryogenic temperature. A settlement there would spend its power budget mining the ability to breathe and the ability to leave. There is a genuine advantage on the other side of that ledger. Titan's escape velocity is only about 2.5 kilometers per second against Earth's 11. Leaving Titan is easy in the sense that matters most to a rocket. Making the propellant is the hard part, and the dense atmosphere means a launch vehicle fights significant drag on the way up, though that same atmosphere makes arriving much cheaper because a spacecraft can be slowed by the air rather than by fuel. Then there is what years in that environment would do to a body, and here the honest answer is that nobody knows. Titan's gravity is about 1/7 of Earth's. Enceladus's is about 1/100th. Everything ever learned about the human body in altered gravity has been learned either in free fall, in orbit, or on the surface of this planet. The middle of the range is entirely unmeasured. There is no data on what a seventh of a gravity does to bone density over a decade, or to muscle mass, or to the cardiovascular system, or to the fluid distribution that affects vision, or to the vestibular system that manages balance. There is no known threshold either, no established figure below which a body deteriorates and above which it does not. It may be that a seventh of a gravity is sufficient. It may be that anything short of a full gravity produces slow, cumulative losses. And any settlement in the Saturn system, given 6 or 7 years of transit each way, is not a place people visit. It is a place people go for a decade or not at all, which means the question would be answered by the people living it. A full round trip, including any useful stay, would very likely exceed 20 years. That is longer than any isolated human undertaking on record, in an environment where the nearest other people are a decade away by the fastest available means. There is one piece of that journey worth correcting, though, because it runs against expectation. The radiation problem for a Saturn expedition is not at Saturn. It is on the way. A multi-year cruise through interplanetary space, outside any magnetosphere and outside any atmosphere, accumulates a dose far larger than anything the destination delivers. Arriving at Titan and walking out onto the surface would, in radiation terms, be a considerable relief. The journey is the hazard. The moon is the shelter. Whatever human presence eventually exists in that system would almost certainly be split in two. A surface base on Titan for shelter, materials, atmosphere, and the extraordinary advantage of a thick sky. And separate infrastructure in orbit or on a small moon for launch, communication, and observation, because Titan's atmosphere, which protects everything under it, also blocks the view of everything above it. The moon that is easiest to live on is the moon from which nothing can be seen. That leaves the honest list of things that are not known, and it is worth reading out plainly, because an episode like this should end with the shape of the uncertainty rather than a false resolution. Whether Titan's methane is being resupplied from the interior, or whether the atmosphere that makes it comfortable is a passing condition, is not known. Whether Enceladus's ocean holds life is not known, and the question cannot be answered without either sampling the plume far more carefully than has yet been done, or cutting through the ice, one of which risks contamination and the other of which more or less guarantees it. Whether Mimas's inferred ocean is really there, and how many other apparently dead moons in that system are hiding one under an unmarked surface, is not known. What built the ridge across Iapetus is not known. How old the rings are, and how quickly they are ending, is estimated rather than established. And whether any human body can live for a decade at a seventh of a gravity, under artificial light, without a horizon or a compass or a sky, is not known either, and it is the question that would decide everything else. What can be said with confidence is smaller and stranger than any of that. The Saturn system is the friendliest place in the outer solar system, and it is friendly in ways that are entirely real. The radiation is manageable. The water is effectively unlimited. There is a moon with a nitrogen sky at a pressure a body can tolerate, where a person could walk outside in a coat and a mask, in adequate light, on solid ground, beside a sea, in weather. There is nowhere else beyond Earth that offers that combination, and there probably never will be. And every part of it is made of something else. The sky has no oxygen. The sea is fuel. The rain falls once a generation. The beach was manufactured in the atmosphere and clings to whatever it touches. The bedrock is ice as hard as stone, and it holds all the oxygen there is. The ocean that could be sampled most easily is the one that argues hardest for being left alone. The best view of Saturn belongs to the emptiest moon in the system, and the great structure that view looks out on is quietly falling down. That is what makes the Saturn system worth thinking about carefully rather than casually. It is not that it says no. It is that it says yes to everything, in the wrong material, and it does so without any intention at all, having arranged itself that way over 4.5 billion years for reasons that had nothing to do with anybody. And so we leave them turning where they have always turned, a moon with a shoreline no one can drink from, a moon breathing its ocean out into the dark, and a ring of ice slowly coming down like weather. None of it is waiting for us, and none of it needs us to be there. Let your breathing slow. Let the day settle out of you. Sleep well, and good night.